Hello students, my name is Sumit Sagar Hota. I am a PMR PhD student at IIT Palakkad, and today we will discuss lecture 41 to lecture 45 by Professor Ashok Desai IIT Kanpur of the subject Introduction to Airbreathing and Propulsion by NPTEL. This is the week 9 of the live discussion section. In this section, we will see some of the MCQs and we will solve some of the problems in this section. Let's start the section. Okay, so Navier-Stokes equation is the conservation of what? Momentum. Okay. So Navier-Stokes equation is the conservation of momentum. Okay. Yes. The centrifugal compressor is an dash. The centrifugal compressor is a reversible process under some circumstances. Okay. Okay. Okay, in a centrifugal compressor flow is a dash. Okay, always centrifugal compressor flow is a radial flow. Okay. Okay. Then in a centrifugal compressor, the centrifugal energy present in the gas is utilized to what? Obviously compression means it's going to compress, okay, to do the work. Okay. Compress means here it is to do the work. Okay. Uh, the centrifugal compressor. Okay, so the centrifugal compressor delivers what? Delivers the low flow capacity. So the centrifugal compressor delivers the what? A low flow capacity. Okay, so this is a disadvantage of a what? Centrifugal compressor. So the rotating speed of a centrifugal compressor is dash the function of diameter to be maintained. Okay, it's inverse. Okay. Okay, so dash has large change in inlet to exit radius when compared to the centrifugal compressor. Okay, so obviously axial compressor. Okay, so having higher change in the axial compressor is having a higher change in the inlet to exit radius as compared to the centrifugal compressor. चलो the first part in both the centrifugal compressor and the axial compressors are similar. This is actually a true statement. Okay. The centrifugal compressor dash the energy by increasing the radius, where centrifugal fan decreases the energy. Okay. The centrifugal compressor decreases the energy by increasing the radius, where a centrifugal fan decreases the energy. So if the radius of centrifugal compressor increases, when the radius of the centrifugal compressor increases, the energy of centrifugal compressor decreases. Okay, so that's what the game. So radius is inversely proportional to the energy. Okay. Okay. Okay, but if the same thing applied to a fan, okay, more specifically centrifugal fan, okay, okay, okay. The centrifugal compressor increases the density of the fluid more than dash. Answer is more than 5%. Okay. Okay. So the centrifugal compressor increases the density of a fluid more than. So this is the density of the fluid. Okay, so that's what the game. So the density of the fluid increases due to the centrifugal compressor by what? 5%. More than 5% it will increase. Okay. The centrifugal fan has a relative fluid velocity of what? Okay, for the centrifugal fan having a relative velocity what? Less than Mach number 3. Okay. What is the pressure coefficient of a centrifugal compressor, and then derive that. Okay. So, what is the pressure coefficient of a centrifugal compressor? Okay, let this pressure coefficient of the centrifugal compressor be psi p, and we have to derive that. Okay, so what we need to prove is psi p is equal to 1 minus phi 2 cot beta 2, where beta 2 is your blade angle at outlet and phi 2 is your flow coefficient. Okay, and psi p is your pressure coefficient. Pressure coefficient, and this is a flow coefficient. Okay, and blade angle at outlet. Okay, so what is psi p? Psi p is equal to h divided by u2 square by g. So H is equal to heat developed is equal to Bw2 U2 minus Bw1 U1, okay, divided by G. Okay, so heat developed is equal to Bw2 U2 minus Bw1 U1 divided by G. Okay, so for centrifugal compressor, Bw1 equal to 0, B1 is equal to Bf1. Okay, so now you have to reduce this expression to, okay, then now what will be H? So H is implies H is equal to Bw2 U2 divided by G. Okay, so so next we know one thing. What is Bw2? The Bw2 is equal to U2 minus Bf2 into cot beta 2. So substitute the Bw2 in the S equation. S is equal to U2 minus Bf2 into cot beta 2 into U2 divided by G. Okay, so okay, so now this is your H. So what is your, if you know the H, then you can actually now put it in the what, psi p equal to H by U2 square by G. Okay, next now find out the psi p. Psi p is equal to U2 minus Bf2 cot beta 2 U2 divided by G into U2 square by G. Okay, so G get cancelled, U2 and U2 get cancelled. So U2 G. Okay, so is equal to okay, so U2 minus Bf2 into cot beta 2 divided by U2. Okay, now let's just rearrange. One minus Bf2 by U2 cot beta 2. Okay, so phi 2 is equal to Bf2 by U2. Okay, now what is your psi p? Psi p is equal to 1 minus phi 2 cot beta 2. Okay, this is actually now proved. Okay, In a double-sided centrifugal compressor, the following data are given. Overall diameter of the impeller is 50 cm, eye root diameter is 15 cm, eye tip diameter is 30 cm, RPM is 15,000, inlet total head temperature is 295 Kelvin, power input factor is 1.04, total mass flow is 18 kg per second, total head isentropic efficiency is 78%, slip factor is 0.9. Assume that the velocity of air at inlet is 150 meter per second and is axial and remains constant across the eye annulus. Find the total head pressure ratio, the power required to drive the compressor, and the inlet angle of the vane at the root and tip impeller eye. Draw the TH diagram and velocity triangle. Okay. Okay, so for this question we have to first of all write down the given and you have to draw the velocity triangle. Okay. So what are the things given? D2 30 centimeter, 5W 1.04, 5S 0.9, D1 15 centimeter, N 15,000 RPM, M dot 18 kg per second, and then T1 295 Kelvin, and isentropic efficiency of 0.78. then V1 is equal to Vf1 is equal to Vf2 150 meter per second. Okay, so let's draw the TS diagram and then solve it. Okay, so what is the T2? Let's do the solution. T2 is by T1 is equal to Rp to the power gamma minus 1 by gamma. So pi into 0.3 into 15,000 rpm. Okay, divided by 60. So you now find out the what U2. So power required to drive the compressor, we need to find out the power required. Okay, चलो चलते हैं हमारी. Okay, so just now solve it and find out the power required. Okay, so P is equal to 0.94 megawatt. Okay, this is your answer. Okay, for the second bit. Okay. So next we will also from the power we know that P equal to m dot Cp delta T. Okay, so P is equal to m dot Cp into T2 minus T1. So substitute all these value and find out the value of T2. So what is the isentropic efficiency? equal to 0.78 is equal to T2s minus T1 divided by T2 minus T1. Okay, just find out T2s from here. T2s is equal to 295 plus 0.78 into 347 minus 295. Okay, so next will be what? T2s. Okay, so now you know very well T2, we have the T2s. So what we need? We need to find out the pressure ratio, RP. Okay, so T2s by T1 is equal to RP to the power gamma minus 1 by gamma. Okay, so we need to actually find out RP is equal to T2s by T1 to the power gamma by gamma minus 1. Okay, substitute all these values. 35.56 divided by 295, then 1.4 by 0.4, RP equal to 1.56. Okay, next we'll find out U1. What is U1? Pi T1 n by 60. Okay, so theta is the Venn angle at the root. And phi is the Venn angle at I. So now find out the tan theta. V1 by U1 is equal to 150 divided by 117.5. Theta equal to tan inverse 150 by 117.75. Now what is theta? Theta is equal to 51.86 degree. Okay, this is your answer. Okay, now the third bit. Wow. Okay, so now find out the phi s. Phi s is equal to VW2 by U2. So VW2 is equal to phi s into U2. Phi s is your 0.9, U2 is your 235.5. So what is your VW2? VW2 is equal to 211.95 meter per second. Okay, so what is tan phi? Tan phi is equal to Vf2 divided by U2 minus Vw2 is equal to 150 divided by 235.5 minus 211.95. Okay, so what is a 5? Tan inverse 211.95. Okay, so is equal to phi is equal to 81.07 degree. Okay, so okay, so we have the phi. Okay, okay, so next question. Okay, so phi. So now it's now next question. Okay, okay. So the question is a gas turbine. A gas turbine utilizes two-stage centrifugal compressor. The pressure ratio of the first and second stage are 2.5, 2.5 and 2.1 respectively. The flow of the air is 10 kg per second. This air being drawn at 1.013 bar and 20 degrees Celsius if the temperature drop in the intercooler is 60 degrees Celsius and the isentropic efficiency is 90% of each stage, then calculate the actual temperature at the end of the each stage and the total compressor power. Okay. So first we draw the cycle, then we'll start solving the problem. So chalo P3 T4s, okay, and then P2 T2s, this is your P2 T3, okay, and this is your P1 T1, okay. So this is your T2 and this is your T4, okay. So let's write down what are the things given. Okay. So m dot is equal to 10 kg per second, P2 by P1 2.5, P3 by P2 2.1, P1 is equal to 101.3 kilopascal, then T1 is equal to 293 Kelvin, okay. So what is T2 minus T3? T2 minus T3 is equal to 60 degrees Celsius and isentropic efficiency so T2 minus T3 given as what? 60 degrees Celsius and isentropic efficiency of what? 0.9, okay. So let's go to the solution. So T2s is equal to T1 into P2 by P1 to the power gamma minus 1 by gamma, 293, 2.5, 0.4 by 1.4. Okay. So T2s is equal to 380.68 Kelvin. Okay. So what is the isentropic efficiency? So let's do it. T2. So what is T2? 293 plus 38.68 minus 293 divided by 0.9. Then what is T2? T2 is equal to 390.43 Kelvin. So okay, so what is T2 minus T3? The T2 minus T3 is equal to what? 60 Kelvin or 60 degrees Celsius. So substitute T2 and find it in terms of what? Kelvin, because T2 it is in what? Kelvin. 390.43 minus T3 is equal to 60 Kelvin. So T3 is equal to 330.43 Kelvin. Okay. So now you have T3. So let's go for your so T4s. What is T4s? T3 P3 by P2 gamma minus 1 by gamma. Three 30.43, 2.1, 0.4 by 1.4. Okay, so T4s is your 408.45 Kelvin. Okay, so what is T4? T4 is equal to T3 plus T4s minus T3 divided by 0.9. Okay, so what is T3? 330.43 plus 408.45 minus 330.43 divided by 0.9. So what is T4 then? T4 is equal to 417.12 Kelvin. Okay. Now if you see, we have T4, we have T4s, T3 and T2. Okay, that means whatever the required for the compressor power, if you see in the equation, we need for the compressor power, okay, T2, T1, okay, so T1, T2 to then T4 and T3, all these things we need. Okay, so all these things data are available So basically, if you see, this is your PC2 and this is your PC1. PC is your compressor power. Okay. So what is the compressor power? So PC is equal to PC1 plus PC2. Okay, is equal to m dot Cp T2 minus T1 plus T4 minus T3. Okay, what is m dot? 10 Cp 1.005, then it is 390.43 minus 293 plus 417.12 minus 330.43. Okay, so now you have to just calculate all these values, and by solving you will get the PC as, what is the compressor power as, in terms of kilowatt, 1850.406 kilowatt. Okay, so there is some problem in the connection. Okay, so basically I just calculated this PC value. Okay, and it comes in terms of the what, kilowatt. Okay, okay. So in the question actually it's asked the actual temperature at the end of each stage. Okay, end of the stage means what, you need the temperature T4 and T2. Okay, T2 and T4 already find out. Okay, and then we'll also find out the what, compressor power. So this is your answer. Then T4s, T4 is also your answer. Okay, next this is your answer. Okay. Thank you very much for attending the section. If you are attending the recorded one also, thank you very much. If there is any doubt in the section, feel free to ask the questions in the comment section of my YouTube channel, Sumit Sagar Hota. And if there is any question related to the lectures, you can ask in the question and answer forum of the NPTEL. Thank you very much. Have a nice day. Good night, and we'll meet next week, same 6 to 8 p.m. Saturday. Thank you very much. Good night.